it's recording.
Okay, everyone ready here? I'm Mr. Peterson. I'm one of the 3 safety mentors, along with Mrs. Peterson and Mr. Ward. And safety in FIRST robotics is very important. There's even an award for it. And in the past, we've done quite well in that. Actually, our first award at World Championships was the UL Safety Award. And last year's safety captain, Connor Colleen, worked very hard at that. And this year's safety captain, Jackson, is going to do even better.
Well,
Our safety
Connor was the first year captain. That was the only year he was even on the team. So, and that's because everybody needs to know safety. It's not just the safety captain's job.
Yes, our safety sub-team even has a mission statement, as you can see, to provide the tools, training, and oversight for FIRST Team 2222 operate in a safe manner in all aspects of their work, including in the school workshops, like here, at competitions, and at outreach events. That was our original statement, and we added this second one, to establish a lifelong culture of safety within the team and spread that culture to the community. That's when we branched out, when we began our outreach. We trained other teams. We gave them safety manuals and everything that they needed. And that's when we really stepped it up, and that's when we won awards for all the good work we've done. Want to go on to the next one? So that's why we're having these, and tonight, one of our mentors, Mr. Swanson, he's a manager at 3M in the Personal Safety Division. He is going to give a speech on personal protective equipment, such as safety glasses. Everybody has safety glasses? And they protect you. You can still use that. You're still okay. The safety glasses take it for you. Whether it's metal chips, hammers, flying robots, who knows? They protect you, but that's just one piece of it. Mr. Swanson will explain the rest of it.
You got a question over there.
What? Question?
So, just how strong are safety glasses? I guess you hammered them, but...
Well, they're made of a special material. It's polycarbonate. There's all kinds of clear plastics, like acrylics and stuff to make fish tanks out of. But we're actually not allowed to use those on our robots. I'm a robot inspector, and that's one of the things I'll always ask, what kind of, if I see clear plastic, what kind of plastic are you using? If it's acrylic, you can't have it on the robot. It has to be removed. It has to be polycarbonate. Polycarbonate is what they make bulletproof glass out of. One of its characteristics is it's extremely tough, meaning that it doesn't shatter like glass or acrylic. It will absorb the force of a hammer or a nail or a bullet within its matrix. How strong it really is depends on how thick it is. But
So all safety glasses have to meet what's called an ANSI standard, American National Standards Institute. And the way they test it is they fire a ball bearing at the glass of a certain weight and size. And if it doesn't crack, then it passes. So you can exceed that threshold, but that's the minimum it has to do. So they have, the American National Standards Institute has a minimum threshold that all safety glasses have to meet. That's okay. To answer, I mean, there's an actual mathematical formula where the velocity and the size of the ball bearing, et cetera, that they use. But they're very strong, to Mr. Peterson's point. So, you want to flip over to, are you done? No, all right. We're going to flip over and see if, oh, look at that. Let's hope it works. Maybe, yeah. Yep, good, I got a clicker too. Okay, so there's going to be some graphic images in here. I'm telling you that now, in case you have a little bit of a squeamish stomach, there's going to be some things that are rather graphic. But we're going to talk about, I love that presentation. That's the practical application of what you need to do when something goes wrong, right? I mean, there's a situation that requires help. This is hopefully so you don't ever get to that. Best case scenario, you never get there. Nobody ever wants to have to triage somebody. That's bad. So let's try and avoid that. So I'm going to walk you through a couple of things. The first is something that most companies have to face, and this is something that you guys should do. And this is the heart and soul of what safety is in the United States. It's this: you have to recognize potential hazards. And if you can recognize there's a hazard, let me put it this way. I sit on my butt in an office all day long over in Maplewood, Minnesota. My company can anticipate I'm not going to be in much danger, right? But if I get transferred to one of our manufacturing plants, they can anticipate there's going to be some dangers that I'm going to face. Flying objects, loud noises, gases, vapors from paint fumes or paints or welding fumes, etc. Right? So then if they anticipate the hazard, you guys should anticipate where you have hazards. Where do you think you have hazards around here? In the shop? I heard everywhere too. All right. Everywhere's broad, but there's hazards everywhere. You can't measure everywhere. But you can measure the places where you know there's problems. So how loud does it get? Is there flying debris? Is somebody welding? Is somebody painting, right? So if you can anticipate, you have to control that hazard. You have to do something. One of the things you can do is engineer the problem out, right? You could build, let's say you're going to be grinding over here, or you're going to be abrading something. You could build a great big plexiglass wall and put robot arms inside. You could just work a joystick and you'd be safe behind that wall, right? That's engineering the solution out. The more logical thing is for you to put on some sort of protective equipment to protect yourselves. And that's what most places do. So we're going to talk about a couple of things. We're going to talk about respiratory, we're going to talk about hearing, and we're going to talk about eye protection. Because those are the most common ones you guys are going to face here. So, respiratory protection. Do you guys know what we mean by respiratory? It hits your lungs, right? So things you breathe in can be very damaging to you. So you would wear a face piece, something to protect your lungs. It's tight fitting, usually. They do make loose fitting, but that has a blower motor, etc. on it. So you wear something like that with a blower motor pushing air into you. But tight fitting, so it keeps the particulates, whatever is in the air, out from going into your lungs. So when we talk, we're going to talk about negative pressure, because that's what you're going to be using more on. You're not going to probably get into airline or self-contained breathing apparatus. Did you guys know that SCUBA was an acronym? When you go scuba diving, it's self-contained underwater breathing apparatus, right? So if you're not underwater, it's just SCBA, just for fun. Scuba, yeah, it doesn't have nearly the same ring to it, does it? So, wow, that's really high. Types of things you're going to face. Dust. It sounds silly to talk about dust, but dust can get into your lungs, cause problems. You might go home, blow your nose, and see a whole bunch of black stuff because you've been cleaning up in the shop, you've been doing something. There's a lot of particulate. You were raking leaves. How many of you had to rake leaves this fall? How many of you then sneezed and went, oh dear God, look at that. Yeah, it's really gross because all of that is a particulate that got into your body. Now in that case, your nasal cavity did the right job. It was trying to filter as much as it could, but some of that could have gotten into your lungs. Dust, mist. Anybody, if you're back in that paint booth, there's going to be mist. There's going to be overspray coming out of that, right? You need to be protected from the chemicals and the overspray that's coming out of that. Metal, if you're welding, metal that's being burnt off is actually a particle. It's not a gas or a vapor. A fume is a particle. Those little tiny pieces of metal that are so hot they're floating, and when you breathe them in and then they cool off inside your lungs, now you have little pieces of metal shard inside your lungs. So it's very dangerous to be welding without respiratory protection. You also need eye protection when you're welding, right? Who else needs eye protection if I'm welding? Everybody around me, because that arc is going to affect everybody who can see it. Even if you're not looking at it, if you're just standing near it. It's like a really, really hot sunburn coming off and hitting your eyeball. So everybody needs to. That's why you have a welding booth back there with those pieces of red plastic hanging down to try and drop that. Gases and vapors, you'll run into this if you're cleaning anything with solvents, or if you're painting, or anywhere where you're opening a can that probably says danger somewhere on there. You're going to run into gases or vapors. You'll see a lot of them. we make specific respirators for gases and vapors. They're not the same, they're not the white ones. Those white ones that you see are for particulates. We make others because one protects against particles and the other protects against gases and vapors. So you have to know what the hazard is you're facing. Understand, if it looks dangerous, ask somebody. Ask a mentor, ask a safety manager. Say, should I be opening this can of chemicals in this room if nobody's protected? Okay. Places, this is typically what we tell people you'll see, and how many of these things do you guys do here? A lot of them, right? I'm guessing you sand, I'm guessing you saw, you cut, you grind, you weld, you do things out in that shop that create hazards. All of these are potential hazards in your world. So, short-term effects. What happens to your lungs in the short term? Coughing, right? Discomfort, right? You might get nauseous if it gets too thick in there. You might actually get tired and it throws up. And if you get tired, do you make more mistakes if you're tired? Yeah, what if you make a mistake when you're doing something with a bandsaw? Not a good time to be tired, right? As she yawns. Is it because I said tired? Did that make you yawn? If I yawn, well, everybody yawn. No, okay. All right. Oh, I got one. Okay, long-term effects. This can kill you, long-term. You can get cancer from the things you breathe in the shop. If you are female and you're going to have children, you can have birth defects. Your child could have birth defects. It can weaken your immune system. All of these things are longer-term effects that happen to you. This is a picture of a really good lung. That's what a lung looks like when it's healthy. That's not so healthy, and even less healthy. It diminishes your capacity to breathe, right? It creates a longer-term problem for you. So there's a whole bunch of other organs that can be affected besides your lungs, right? You can get into situations where your liver, your kidneys all start to have issues because of what happens in your lungs gets into your bloodstream and then filters into the rest of your body. So I'm going to shift from respiratory and talk about hearing. But before I go on to hearing, are there any respiratory questions? So again, respiratory breathing, you're breathing in and out. That's a good thing. We want to keep you doing that. All right, hearing questions. How loud is too loud? Anybody want to take a guess? How many decibels does it take before you should put on hearing protection?
90.
90 is a really good guess, you rotten. You know this. 90 is the right answer. It's a good answer too. But if it's 90 decibels, and I'll put up a chart in a minute to show you some of the things that make 90 decibels. But if you have to shout to be heard 3 feet away, no, I can tell you, it might have a problem with that. But if you have to shout to be heard this far away, it's over 90 decibels. You need hearing protection because you're damaging your ears. So we typically say, start putting it on at 85. You start to lose a little bit at 85. But OSHA's requirement is 90 decibels. Anything over 90 decibels, in the workplace, now I know you're not in the workplace, but let's assume you're working here, because you are, you should be wearing hearing protection. Now this is a logarithmic scale. That's over an 8-hour time period. So if that goes up to 100, it's going to be a much shorter time period. It's not going to be 8 hours. We'll show you the chart in a minute. But here's an example of some of the things that put out over 90 decibels, right? Welder air grinder, an impact wrench, an air chisel. You're getting up to 112 decibels, right? Here's the time frame. You get to 112 decibels, it's less than a minute. The requirement is you put hearing protection on because you're going to hurt your ears. You're going to damage your hearing. How many of you can just tough it out? You can just flex your ear muscles and keep that noise from hitting you. You can? You're the only human in the world that can flex that ear muscle to keep yourself from hearing. So let's talk about how the ear works. You got this nice big channel right here, that auditory canal. It channels sound in. Your ear is designed, right, to filter the sound I'm putting out to bring into your ear canal. And sound goes in and it starts hitting that eardrum. And that eardrum starts flexing. And that flexing starts moving those little bones, the smallest bones of your body inside your ear, starts moving those little bones. And those little bones connect to a big sac of fluid that's tied to a cochlea. And your cochlea is this little spirally thing right here. And inside your cochlea are cilia, little pieces of hair that are just firing like crazy. As I'm talking right now, inside your ear, cilia are just going like this like crazy. And they're changing the sound vibration from that eardrum into an electromagnetic signal up to your brain to say, these are the words and the sounds Eric is making to you right now. And your brain's decoding that because you understand English and I'm speaking English, you can understand what I'm saying, right? Otherwise you just hear me making noise. But because we both speak the same language, you can understand that. But that's what's going on inside your head. What happens if you beat them up? It gets really loud for a long time. They start to get a little tired. Like everything, you're beating it up over time. So you go to, somebody tell me who's popular in music right now. Taylor Swift? I don't know. Who's popular right now? Taylor Swift? I got a thumbs up. Okay. You go to a Taylor Swift concert, and it's 115 decibels. And it's boom, 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 hitting you for 2 hours straight. Those things start falling over. They're not moving. You walk out, what does it sound like? Everything's a little muffled, isn't it? It's because they're not moving. You can't make them feel stronger again. You have to give them time to rest. Hours and hours. Maybe even the next day you might still be having a little problem. If they break off because they've been beat up too much, they don't move at all. And you become deaf. You start to go deaf as those break off. You want to know the best way to design a system to go deaf? Build speakers and put them right in your ears. And then connect them to say something that plays music. And turn it up to 115 decibels while you're doing your homework. You're going deaf. Teenage deafness is the fastest growing group of people going deaf in the United States. Faster than people in their 70s and 80s. You guys are going deaf faster than they are. You're not going to be able, it's a funny joke, it is. I do it all the time. What? You know, it's funny. Until you can't hear your child laugh. You can't hear a loved one say something. It's pretty rough. So, best way to protect yourself? Shove something in your ear. Put an earmuff on. Block that sound from getting in there. Lower the threshold below 90 decibels. Don't turn the music up all the way when you're listening to it. It's okay to listen to music. It's a really stupid system to put speakers in your ears, but it's okay to do it. But keep it at a moderate rate. Be able to hear somebody if they say something to you. That's a good way to do it. Passive ear protection is the most commonly chosen way of protecting yourself, right? There is active ear protection, so like a communication device. You might see if you watch the finals in NASCAR the other day, they got headsets on, they're talking to the driver. That's a radio communication, but that's also acting as hearing communication for them. It blocks the sound. Any questions on hearing? Good, because we're going to get really graphic now. Eye protection. Why are most of you wearing eye protection right now? Yeah? So is it because you're not really careful when you're doing stuff and you're trying to protect yourself? No. Little things can fly, right? And what if you're not even the one doing the work? What if I'm over here doing the work? Doesn't matter, right? You're wearing it because you or somebody around you might be creating a hazard that's going to hurt you badly. So, over 2,000 eye injuries in the United States every single day in the workplace. That doesn't even count outside of the workplace, just in the workplace. Over 2,000 people have an eye injury. It's one of the most common injuries. The most common injury, want to guess? Want to guess?
Heads.
Cuts. Cuts to the hand. Cuts are the #1 injury. Eyes are up there. They're in the top 5. It's one of the biggest injuries. It's also a very expensive injury. Doesn't sound bad. $1,000, $1,300 is the average cost. But then you've got lost productivity. You can't do your homework because you can't see. Or you can't do whatever it is you're supposed to be doing. You can't cut the grass. Now that sounds like a good thing, but then the grass doesn't get cut. All right? So there's lost productivity. You can't come to robotics. You can't do certain things that you want to do. So this is what happens when somebody else is doing something and a piece of metal might come flying out of the and hit you right in the eyeball if you're not wearing your eye protection. If you're wearing it on top of your head because it looks good instead of over your eyes, right? And by the way, eye protection, I'm going to go back just because it is pretty graphic. Eye protection is the one area in safety products that everybody tries to look good in. How important is it to look good in? 0. It's not. It should fit you. It should be comfortable. It should fit you and cover you. I'm wearing glasses. Are these protecting me? Would this work in a shop environment? Not at all, because there's way too big a gap here. I'm not wearing safety glasses. I should either wear over-the-glass glasses or wear prescription glasses or wear my contacts and put on regular safety glasses. But there should be a nice, it doesn't have to seal like a respirator does, but there should be a nice tight seal so that flying objects like these can't come flying out of the woodwork and hit you right in the eye. That's a nail. Somebody was shooting off, they weren't shooting at the person, it literally ricocheted off of a hard piece of trim and ricocheted back into a person's eye. That's what happens to your eye, like a bruise on your arm or on your leg. That's what happens when you get blunt trauma to your eye. This is what happens when you're welding. It's called arc eye. It feels like your eye like your eyelid is made out of sandpaper. It hurts. For days and days and days, it hurts. It feels, every time you blink, it feels like somebody's scratching sandpaper over your eyeball. That hurts. So, this is just a fun picture that, so we had a customer send in a picture and said, look at what happened with this safety glass, so we tried to recreate it, see if we can do it. And that's where, going back to the earlier question, how strong are they? They're strong enough to stop a nail gun. That's a nail gun held right up to it and shot at it. So it stopped it. So, I can't say it enough. If you have questions about equipment, stuff you're using, ask. Don't be afraid to ask. Don't be afraid to ask a second time. And don't think if you know how to use a piece of equipment, you do. If you do, that's great. But if you're not sure and you're just going to try and wing it, don't do it. We don't want to see anybody losing anything. An arm, a limb, I don't want to see any of that stuff. Okay, that was graphic. Are there questions? If you do this stuff, hopefully you never get to that stuff. All right. Questions? Yeah? Oh, you're going to clap? Were you really going to clap? Go ahead and clap. Thank you very much. And don't shoot ball bearings at glasses to see how strong you are, especially if your face is in them. Just I'm looking at you. I can see you over there thinking about
I think you should stop. Just for 29 minutes. Then they have to stop.